In this video we will have a look how to create a program for CNC machining. First we will create machining program for fixture plate and then for the part itself. The part is this part. It is a dumbbell base and it is made out of plastic. So the features that we need to machine are pockets and holes, and these holes must be tapped. First operation is pocket adaptive clearing. We use 3D adaptive clearing command for this. We use Sandvik 10 mm flat end mill for this purpose. The geometry is pocket bottom. And for optimal load we have 14%, which is 1.4 millimeters, and we use half a millimeter of stock in radial direction. Next we clean the detail pocket contour. For this we use Walter 6 mm flat end mill. We select the bottom contours for this purpose. And here we have roughing passes made, so maximum step over is 0.45 millimeters. And the reason for this is that during roughing process the 10 mm Sandvik tool leaves quite much material in these corners, and for 6 mm tool this is a bit too much, so we use two passes to remove it. Next we make a cleaning pass for our fixture grip clamp pockets, and lastly for our Uniforce clamp pockets. Next we will drill all the pilot holes. For each diameter holes we have our own path, because the depth of the drill is different. And for this we use 10 mm spot drill. The tip angle is 118 degrees. After spot drilling we use drilling command. We drill all of the holes and the drill goes through the material 5 millimeters. And for this purpose we use high-speed steel drills. Next we chamfer all the holes, and for this also, for each set of holes we use our own toolpath, because the chamfer is made using drilling command, so that to make so if you want the chamfer diameter to be 5 millimeters, the tip must go through the hole 2.5 millimeters. And the last is tapping command. Tap goes through the bottom also 5 millimeters. And during machining process we have to use cutting fluid with taps. Now the program for fixture machining is ready. And now we will look how to create a program for part machining. Here we can create machining for part first and second setup. So the first setup is defined followingly. We have defined 6 bodies, 24 fixture bodies, and our stocks, which are selected from the solid models. And the work 0 point is placed in the center of this blocket and on the top of the plate. So first we make our first setup, and we make a face milling operation. For this we use 63mm Mitsubishi face mill, and we make only one pass with it. Next we must machine the contour of the part. We use 2 depth of the tool flute length isn't sufficient to make it with one pass. Next we make the finishing pass. We chamfer the contour and we create another bigger chamfer. And to get these toolpaths to these other parts, we use linear pattern command. This can be made so that we select all the toolpaths, right click and add new pattern, and then pops out this window where we select our edge, the direction, this is this edge here, spacing direction, this is 160mm, and number of instances is 3, and operation should be ordered by the tool. So the operations that we have with one tool, it is made on all the parts, and then the tool change will be made. And now first setup is ready. For second setup, the setup is defined similarly. We have our 6 model bodies, we have selected our fixture bodies, and the model is fixed size box. So first, to avoid thin edges over the part in the face milling, we have to mill the contour first, and for this we use the adaptive command, which removes material from this curved side, and then with contour command we remove it from other sides. And the same is made with the other part as well. And then we use linear pattern to transfer these toolpaths to other parts. Face milling, use linear pattern command. We just select all the bodies. And for the last operation we have chamfering, and for this we also use linear pattern command to transfer toolpaths to other parts. And so we have our programs for first and second setup. For third setup we have another design. In third setup we need to mill the pocket and a hole. For the pocket we use the adaptive clearing command, and we just choose all of the pockets, because here we can't use linear command because the spacing isn't even. And for this we use 10mm Sandvik flattened mill. For the hole we also select all the geometries, and for this we use 6mm Volter flattened mill, and it goes 1mm through the part into the fixture body. And last we make chamfer for this contour. For chamfer we use trace command because this is 3-dimensional chamfer, and it cannot be made with 2D chamfer command. And now we have program for third setup and for all the part itself.